perfect, Alicia, perfect. Okay, so very good. So this one then factors into 2 is your GCF, which leaves 2x plus 3. Nice job. And Emma is finishing this one. Emma, you have one more step. Did you know that? Because you still have your 2 groups. Oh, what is it? You want me to tell you the answer? Emma? Okay. Oh, what to do. Okay, so look at your first group. You have the x and the x plus 6, and then your second group is negative 2 and minus 6, I should say. Oh, yeah, you got it. Good. X minus 2, x minus 6. Yay. Good job, you guys. Everyone, good job. Way to go with your warm-up. I like it. Looks beautiful. Okay. All right. So we are just going to do something quick today. Not that. We are going to find and understand the purpose for excluded values. And some of you guys, you've already talked about those. But I was just thinking that we probably need to talk about them as a group because you're going to be graphing pretty soon. And those excluded values are going to be what you make your asymptotes with. And if you kind of remember back to quarter 3, we did some graphing with some asymptotes. So it might sound familiar, but they're kind of important. Okay, and then finally, important information for success. All right, you guys, if you didn't do week 1, definitely don't start on week 2. For sure, go back to week 1 and do it first. So always do your math in order. Don't ever skip, otherwise it will be really, really hard. In fact, anybody who didn't finish quarter 3, you know, it kind of poses a little bit of a problem with some stuff, but the majority of what you need to know for this quarter is factoring, and you guys are doing a great job with factoring. So if you can factor, you're probably going to be fine. All right. So let's talk about excluded values, you guys. Okay. If we have something like this, 2x minus 1 over x plus 4, as we talked last time, that's a rational expression. It's a fraction. And you guys, anyone can answer this. Can we divide by 0? Can you have division by 0? Division by 0. What do you guys think? No. Thank you, Trevor. Thank you. No, you cannot have division by 0. So what we're wanting to do is figure out, okay, we can't have x be anything that would make our denominator be 0, because if it's 0, we have an undefined fraction, and that's bad. So one way you can do it is just kind of look at it, and you guys can see that if x was negative 4, then negative 4 plus 4 would give you 0, and then you would have division by 0, and that's bad. Another way that you can do it is just set your denominator equal to 0 and figure out what this equals 0, because sometimes people can't always do it in their head, especially if it's a little more complicated than just x plus 4. So if you do that, you get x equals negative 4. And that's another way to figure out what value is excluded. So basically, you guys, the values that are going to be excluded is anything, oh, really, Alicia, you have to go too? No, Alicia, no, yeah. If you divide by 0, you can try it in your calculator. It'll come up with undefined. You can't divide by a 0 because you're dividing by nothing. It's hard to explain, but we can look at that when I see you. Why do you have to go? Oh. But anyway, yeah, so no, you cannot divide by 0. You can have things that you divide into 0, like 0 over 4. That just gives you 0. But you cannot do 4 divided by 0. That is considered undefined, U-N-D, undefined. Okay, so as a result, you guys, all right, Alicia, all right, but do your work, Alicia. I want to see you get a whole week done this week, a whole week. But anyway, so again, you guys, if we're dealing with rational functions, and okay, good, you promised, I'm going to remember. When you're dealing with functions and you graph them, there's going to be places on the graph where you can't have the function, like where x is equal to negative 4, because otherwise you'd have an undefined function. And so you guys will see that later. So for right now, we're just kind of practicing the skill at figuring out what these excluded values are, because they're going to help us later when we're graphing the function. All right, Saxon, see you later too. So you guys, let's go back to our no pods, except for now we don't have student 2 anymore because Saxon left and student 9 is gone. So you guys, look at these note pods and determine what would make you have an excluded value. So Bree, do number 1. Emma, I think you're still there. Do number 4. Trevor, you can do 5. And Miriam, you can do 6, and that'll work out perfect. So you guys see if you can figure out, oops, sorry you guys. See if you can figure out what would make you have division by 0. So Emma, that's what you're doing is what would cause your denominator to be 0? Anything that causes your denominator to be 0 is going to be an excluded value. In the situation that I gave you guys up here, we just had one factor, x plus 4. But when you have something like 1, 2, 3, 4, and 5, all these, well, actually not all of them. Notepod 2 and 5 only has 1x. But otherwise, you might have to look for a couple of excluded values. Denominator is on the bottom. Denominator is on the bottom. Numerator is on the top. Denominator is on the bottom. Okay, so let me see. Let me do for you guys then, since Saxon is gone. Well, actually, that one's kind of an easy one. Let me do number 3 for you guys then, because it doesn't look like anyone's number 3. Well, actually, let me get you guys help. Okay, what would make x minus 4 turn into 0? What value of x would make that turn into 0? What do you guys think? 4, exactly, Bree, 4. So we cannot have x equal to 4 because that would create a 0 in here, and anything times 0 is 0, right? So x cannot be 4. Let's look at our second factor right here, x plus 4. What would make that be 0? What can x not equal here? Very good, Emma, negative 4. So those two values have to be excluded because either one of those values will cause our denominator to be 0, and then we're in trouble. So 4 and negative 4 are our excluded values. And you guys will see that when we graph, those will be called your asymptotes, and those will be these invisible lines that you can't cross. So it's good to understand how to get these values. All right. So good. So Emma's working. Miriam, let me see. You're on number 6. So you got 6, perfect, and 2. Miriam, you are exactly right. Very good. So x cannot be 6, and x cannot be 2. And Trevor, are you working still? Saxon is gone. Okay, oh, Bree, you got yours. So Bree, you have that x cannot be negative 2 and negative 3. You are exactly right. Very, very good. So Emma, you got, what number are you, 4? You are exactly right. Perfect. Because in this first case, x cannot be positive 5, and in the second case, x cannot be negative 5. Exactly. Okay, so Trevor, yours is a little bit harder because you have 2x plus 3, so it's hard to look at it, right? That's one of those ones where I would do this. I would be like, okay, 2x plus 3, what would make that be equal to 0? You don't have to worry about the 2 because there's no x with the 2. You just have to worry about what x value you would plug in here that would make that be 0. So if you set it equal to 0 and solve, then you will figure it out. Oh, Gateway Classroom, had you been paying attention earlier, you would know that is 2. 2 equals 7. I don't know what's going on with the Gateway Classroom right now, but no. You would know that you cannot have division by 0. And it's very important to find these numbers. Guess who? It must be, I don't know. That's a good question. I have a suspicion, but it's just a suspicion. But anyway, you would know that you cannot graph. This is D. D? D. Oh, yes. That was my suspicion all along. The foiler of our math, you guys. We have to do a really good job so that Mrs. D can learn why we cannot have division by 0 with rational expressions. All right, so good, Trevor, good. So you're on the right track. And Okay, so then do you know what your final step is? Okay, so what you've done so far, let's just recap what you did. So you moved the 3 over, which was marvelous, and you end up with 2x equals -3. So Trevor, you still have to isolate your x, right, in order to figure out what your 0 is. So how do you get rid of the 2? What would you do to get rid of your 2? Your 2 of happiness. So you would subtract if you had 2 plus x. But what are the 2 and x doing together? Emma, 5 minutes. Oh no, everybody's leaving so fast. You and Alicia and Saxon, you guys are all deserting me. But I understand. I understand. All right, Trevor. It's okay, Emma. It's okay. So, Trevor, you've got 2 and x together being multiplied. What's your opposite of multiplication? Yes, yes. So, we'll do it together. If we divide by 2, and this is where you might think like, well, what do I do? But you don't have to do anything. You can just leave it as -3/2. So exactly. Very good. You divide. So your excluded value is -3/2, which you know is just -1.5. So when we start to graph these and you start to see these excluded values on the graph as asymptotes, it'll make more sense because you'll have this asymptote at -1.5. And that is something that x cannot be. Does that help actually, Trevor? You had the hard one. Good. So if you think about, let's look at notepad number 2 since Saxon had to go. In this case, he distributed the 3 in, but you don't need to do that because all we have to do is figure out what this x would be. So if we took 3x minus 5, or I guess he actually pulled that from before, equals 0, we would do the same thing that Trevor did and we would solve for x. This one is hard to see, so sometimes you actually have to go through this math in order to see that, hey, x cannot equal 5/3. Okay. All right, you guys. So let's kind of recap this. Excluded values are values that cause your fraction to have division by 0. Okay, and we cannot have division by 0, otherwise we have an undefined fraction. So what are the excluded values? Well, anything that, again, causes your denominator to equal 0. So every place that we have an x, we have to figure out what we could plug in that would cause that piece to be 0. So you guys, what I want to show you right here at the end, in your last lesson, the dividing and multiplying last week, you had to look at excluded values. And it was a little bit complicated because not only did you have just this one expression here, like x over x minus 2, you had division by a whole nother fraction over here, like 2x over x plus 1. So when you think about it, that's still one fraction divided by another fraction. So this other fraction down here, which was the 2x over x plus 1, this whole thing cannot equal 0, right? So it makes it a little bit complicated because you have to find a lot of different excluded values here. So we have to do what we normally do, and we have to look at our denominators, and we have to say, okay, well, x cannot equal 2, and then we have to look at this denominator and say that x cannot equal -1, okay, because no matter what, we can't have division by 0. But now you guys have to consider that anything that would make this second fraction 0 would also not work. Otherwise, we still have division by 0. So because of that, we also then have to examine our numerator. So what would make 2x equal 0? Well, if we divide by 2, we would say that x cannot equal 0. 0 divided by 2 is still 0. So we have 3 excluded values here, which is a lot, which is a lot. So whenever you guys are doing this, I know that the lesson, in order to solve this, has you flip it. It doesn't matter if you look at excluded values after it's flipped or before it's flipped, because no matter what, you're still looking at the numerator and the denominator. So here's what I'm going to have you guys do. Now, Bree, I know you're all alone here because 1, 2, and 3, they left. You're all by yourself. And then for 4, I think Emma might be gone. So Trevor and Miriam, you guys are the last ones remaining. So I'm going to see if you guys can figure this out, okay? And this will be our final task for today. So why don't you guys see if you can find all the excluded values for, oh, Emma, you are here? Oh, you would do this and know how. Oh, but it's time. Is it time? All right, Emma. So then it's just Trevor and Miriam, and then Bree, you're all alone. Oh, that's okay, Emma. I understand. Don't worry. I'll see you soon. Just make sure you do the ticket out, Emma, when you go. All right, so Trevor and Miriam, how do you guys feel about this? Yeah, I'll be at Gateway. I'll see you at Gateway tomorrow, Emma. But I think you've already mastered these. You're on to adding and subtracting rational functions. Sounds good, Emma. Hey, no problem, no problem. You did a lot of work that week before spring break, so very good. Bree, you are mastering this by yourself. All right, Trevor, you got to help Miriam out. Miriam is making a go for it. She's on a roll. Don't leave your partner, Trevor. It's going to make her sad. She's going to cry. Miriam's going to cry. Bye, Emma. Bye. All right, Bree, let's see what you got. You've got -2, good. And you don't have to write the -2 twice. You can just write it once, it's fine. And let's see, you've got the 7, muy bien. All right, Bree, the only thing I don't see is your numerator, right? Let me see if I can draw a little pointer arrow here. Right here. Because if our numerator is 0, then our whole fraction becomes 0. So you just need to add that. Everything else, oh, very good, Bree, very good. Okay, so let's just write down what you have because it looks good to me. So x cannot equal -2, and you have the same thing here, so we don't have to do it twice. X cannot equal 7, which you have, and up here we have at x cannot equal 0. Nice job, Bree, very nice job. All right, Trevor and Miriam, see what you guys have left. All right, so you guys both have 9 and -9, it looks like. So you guys got these. X cannot equal +9 here. X cannot equal -9. Very nice. And here's another -9. And you don't have to write it twice, just so you guys know. All right, Trevor, good. Good, you got that last one figured out. So down here, and that's one of those hard ones, but you're right. So on this one, x cannot equal +5/2. So I like how you guys got that. All right, you're missing 1. You guys figured out there's just 1 left. 1 left. X cannot equal, yay, you guys got it. -3 for this top part, very good. So x cannot equal -3. Yay, nice job. All right, what questions do you guys have about excluded values? What they are, why you can't have them? Any questions? Any questions at all? Trevor, you're good. Excellent, excellent. And Bree is good too. Oh, Trevor, you're gonna leave me. Jeez, no. If you hang on 1 second, Trevor, I'm just about done. Let me just show you your ticket out real quick. Oh, Miriam, good question. You cannot have excluded values because then those values would cause you to have division by 0. So it would cause your fractions to have a denominator of 0, and then they would become undefined. So they would have no meaning. So we always have to figure out when we have a fraction that has a variable in the denominator what the excluded value is so that we can write that down that we don't have division by 0 that way. And it will become really clear for you as to why this is so important as we start to graph these. Because you'll see how these end up graphing. They're kind of strange functions. And you'll see how they'll get up really close to that excluded value, but they'll never actually cross it. So hopefully that helps. But okay, so Trevor, I know that you are waiting too. So you guys, in your ticket out, why do we need to identify excluded values in rational expressions? And then just provide some kind of an example to support your answer. All right, that's it for today, you guys. That's all I have. You guys have a very nice afternoon, and I will hopefully chat with you guys soon. So Trevor, yes, you can go now. Make sure you check all your grades. You guys check my notes, see if there's anything you need help with or that if you need to redo something. But you guys are making great progress. Like I said, you guys are awesome. Bye, Bree. You have a nice day too. Bye, Miriam. See you later, guys.